Okay, so we're going to continue with our exploration of quadratic relations, and we're going to do the first, well, I guess we did the up and down reflection in the x-axis of the parabola. Now we're going to look at the next step. Okay, so let's just review what we did in the first lesson. So a table of values represents a quadratic relation if the second differences are equal. Okay, so if you have a table of values, just sketch one in there. Although I didn't leave much room, sorry. So now we're going to do the first differences would be the difference or subtract, right? That's what difference means. Okay, so negative 12 minus 3 is negative 9. Negative 3 minus 0 is negative 3. 0 minus negative 3 is positive 3. And negative 3 minus 12 is positive 9. So those first differences are not equal. So now let's do the second differences, which is you subtract the first differences. And it doesn't really matter. Most grade 9 teachers start at the bottom, so do the same thing. So negative 9 minus negative 3 is negative 6. Sorry, I'm going to sneak it in there. Negative 3 minus 3, negative 6. 3 minus 9 is negative 6. So if you go the other way, then you would get positive 6. That's no big deal. So to find the second differences, you just subtract the first differences. And so if you're given a table of values, that'll prove if the second differences are equal, then that will prove that a relation is quadratic. You can also look at the graph. So the graph of a quadratic relation is called a parabola. The equation for the axis of symmetry of the base parabola is x equals 0. If the value out front of the x squared is positive, the a value, just like the a value from the last unit, so we've already been dealing with standard form, right? Then if it's greater than 0 or positive, if you don't like greater than and less than, that's fine. Then it opens up, which means the vertex of 0, 0, the bottom point is a maximum. Every other point is... Sorry, that's not... It's a minimum, sorry. Every other point is greater than the vertex. If the a value is less than 0 or negative, oh, there it is right there, negative, then the parabola opens down. And the vertex, which is also in 0, 0, is the maximum. So if it opens up, the vertex is a minimum. If it opens down, then it's a maximum. All the other points are less than that value. And the step pattern is a multiple of 1, 3, 5, and 7. So every time we have a vertex, we can use the vertex in the step pattern to graph the parabola. So that's really, I'll show how it works using a table of values, but then we want to be able to only use the vertex and the step pattern in order to graph parabolas. So there's always the last example in both transformations will be just using the equation. We're not going to use a table of values. So that's what we're moving towards. Okay. So if you look at this one here now, if you like to highlight, get out your highlighter. We have an a value that is not 1. Okay. So I'm going to use my table of values and plug in the numbers. So negative 3 squared is 9 times 2 is 18. Negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. So again, another, we talked about the axis of symmetry, right? So you can see that the values have some symmetry here, which is a property of a parabola, okay? So now we're going to graph the function by looking at the points, the ordered pairs. So negative 3 and 18. Negative 2 and positive 8. Negative 1 and 2. 0, 0. 1, 2. So now you're starting to see that symmetry. 2 and 8. 3 and 18. That was a terrible line. Make a nice smooth curve. Do a better job than me and my Apple Pen. This is not easy to do. That was terrible. Sorry. Okay, so now it says to calculate the step pattern. So when you do that, you always go over 1, right? So over 1, starting at the vertex. It doesn't matter because it is symmetrical. You can go left or you can go right. You should get the same thing. And you can see that here. So if we go over this way 1 and up, we're going up 2. That would be the same thing here, right? You can see the symmetry. Over 1, up 1, oh, up 2, sorry. Over 1, up 1, 2, 3, 4, 5, 6. And then over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're always looking at the step pattern from 1, it's like stepping from 1 point to the next point, okay? Maybe I should write that down. I don't know how to say that. Oh, I know. Okay, so stepping from one point to the next, start at the vertex, and then just you're making steps basically. Okay, so now this is not, remember, this is, oops, that's not what I wanted, sorry. The base step pattern of a parabola is 1, 3, 5, 7. So that is not what we have here. We have 2, 6, and 10. However, it is a multiple of 1, 3, 5, 7. To get to 2, you multiply 2 by 2. Sorry, to get to 2, you multiply 1 by 2. To get to 6, you multiply 3 by 2. To get to 5, you multiply 10 by 2. So 1 times 2, 3 times 2, 5 times 2. And what you'll see is normally when you start to have these numbers out front of the x squared that are not 1, then the values get really big really fast. So yes, you could do 7 times 2, but that's not shown on our graph, okay? So because it just, the grid would have to be huge, which is fine, but when you're trying to fit it on a slide here, that's difficult to do, okay? So we have 1 times 2, which is 2, 3 times 2, which is 6, 5 times 2, which is 10, and that's what we see here. Okay, so the step pattern has been changed. And this will work for every A value. You can manipulate the basic step pattern. By the same value. And what value is it? Oh, take a look. The A value out front here was 2. Oh, sorry, I made that really dark now. The A value out front here was 2. And so we multiply this step pattern by 2. So then the way that we write it is 1A, 3A, 5, 5A, 7A. Okay, so this is important. So when A is not equal to 1, then you multiply the A value by 1, 3, 5, and 7. Okay, so that can help you to draw a parabola without making a table of values. Okay, so consider the following relation. I don't know why there's an S there, sorry. Y equals negative 3x squared. So we saw this, yes, are in 4.1. This means opens down. Okay, so we already know that, but now we're going to deal with the A value. Okay, so we have negative 3 squared. So negative 3 squared is 9 times negative 3 is negative 27. Negative 2 squared is 4 times negative 3 is negative 12. Negative 1 squared is 1 times negative 3 is negative 3. 0 squared times negative 3 is 0. 1 squared, so again, we're going to get the symmetry. Negative 3, 2 squared is 4 times negative 3 is negative 12. 3 squared is 9 times negative 3 is negative 27. Okay, so now you can see how big we got. So it is not easy to see on this, but the Y values go, it's 3 units per square. Okay, to try to help accommodate. So this is negative 3, this is negative 6, this is negative 9, negative 12, negative 15, negative 18, negative 21, negative 24, negative 27. Okay, so if that is hard to see on your grid, either get some graph paper, make a new grid, or write them in there. Okay, so we're going to do negative 3, negative 27, negative 2, negative 12, negative 1, negative 3, negative 3, again seeing the symmetry, negative 2, or positive 2, negative 12, positive 3, negative 27. So this sometimes is called, people call this it looks skinnier. So it's called a vertical stretch. And then you're going to see what happens when you have a fraction or a number less than 1 or less than 0 under the, less than 1. As the A value, you're going to get it almost, people say it looks fatter, and we call that a vertical compression. Okay. So we have started the vertex, calculate the step pattern. So again, this is why it was important to say that it's 3 units per square. So we go over 1 and down 3, over 1 and down 3, 6, 9, over 1 and down 3, 6, 9, 12, 15. Okay. So start at vertex, over 1, down 3, over 1, down 9, over 1, down 15. So then again, if we notice from the original pattern of y equals x squared, then you can do, we're going to do the manipulate the basic step pattern formula. I'm just going to highlight that again. And look at the a value. You can include the negative because then that negative tells you that you go down. So if you want to make a note for that for yourself as well, the parabola opens down because it's a negative number. Okay? All right. So making a table of values, we want to be quicker. That's too arduous. So let's do this. So graph using, it says using vertex and using step pattern. So what I recommend you do, you write down what the vertex is, and we still have the base parabola vertex of 0, 0. That's going to be our first point. And then we're going to do the step pattern. And I would show your work. Like I said, usually we don't get up to 7, and that's fine. Okay, 1, 3, 5. So 1 times 0.5, 3 times 0.5, and 5 times 0.5, which is 0.5, 1.5, and 2.5. Okay, so start at 0, 0, go over 1, up a half. No problem. Over 1, up 1.5. Over 1, up 2.5. Over 1, up a half. Over 1, up 1.5. Over 1, up 2.5. So now you can see, like I said, this looks like a fat parabola, so to speak. Oops. So we call this a vertical compression. And when you, let's say you're doing this and you want to make sure you label what your line is, or if you have different colors, like it's easy for me here to make it a different color, you can do that as well. Okay, so still have the base vertex. Actually, to be honest, even start writing opens up because you're going to do that later on as well. This one opens down, and we'll do the step pattern. -2, -6, and -10. Okay, so you're going to start at 0, 0, go over 1, down 2, over 1, down 6, 1, 2, 3, 4, 5, 6, over 1, down 10. 1, 2, 3, oops, sorry. 1, 2, 3, oops, over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 1, down 2, over 1, down 6, 1, 2, 3, 4, 5, 6, over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, do a better job than I do. Okay, so if you want, this is called when you have a fraction. Then it's called a vertical compression. And when a is greater than 1, it's called a vertical stretch. So nearing the end of this unit, we'll use those words more often, but you might as well get used to it now. Okay? All right. So on to another translation or transformation. This time we're going to now look at what happens when you have a number, and I'm going to pick a different color, back here. So now you can see here, it's not a number in front of the x squared, it's one of the c values, for example. So we're going to do table of values first. So we're going to do negative 3 squared is 9 minus 2 is 7. Negative 2 squared is 4 minus 2 is 2. Negative 1 squared is 1 minus 2 is negative 1. 0 squared minus 2 is negative 2. So here we go. This is not 0, 0 is not one of our points anymore, and that's going to be a big deal. Okay, so here we have negative 3, positive 7. Negative 2, positive 2. Negative 1, oh, sorry. Oops. Negative 1, negative 1. 0, negative 2. 1, negative 1. 2, positive 2. 3, positive 7. Okay, so we're going to calculate the step pattern. That's what B says. So over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. Okay, so that doesn't change. What do you notice about the original step pattern? It's the same. It's 1, 3, 5, 7. So this time we're not changing the step pattern. Excuse me. So what do you notice about the vertex? So the original vertex again is 0, 0. Now our new vertex, this point down here is the vertex. It is 0, negative 2. Okay, so it has been shifted down 2. Okay, and notice the c value at the end here was negative 2, and negative in the negative direction in a graph is down. Okay, so let's look at what happens when it's positive. So this is a little bit tricky because it's a combo. We have a negative sign, so it opens down. We have a 2 here, which affects the step pattern. And then we have this new thing at the end here, this negative 8. So what are we going to do? So let's do the, oops, I forgot the end there. Let's do the table of values first, okay? So negative 3 squared is 9 times negative 2 is negative 18 plus 8 is negative 10. Negative 2 squared is 4 times negative 2 is negative 8 plus 8 is 0. Negative 1 squared is 1 times negative 2 is negative 2 plus 8 is positive 6. 0 squared times 2 is 0 plus 8 is going to be positive 8. And then we're going to see the symmetry. 1 squared is 1 times negative 2 makes positive 6, 0, and negative 10. So let's pop the points. Okay, so let's calculate the step pattern. So over 1, down 2, over 1, down 1, 1, 2, 3, 4, 5, 6, over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the step pattern has been changed from 1 3, and 5 to down, -2, -6, -10. So we saw that one already. But then the original vertex, which is 0, 0, now has been changed into 0, 8. So now again, this time the 8 and the positive 8. So it's been shifted up 8 units. Okay, so when it's positive, the positive value at the end, or this positive C value, it's going to go up. If it's negative, it's going to go down, which is really, what you've seen before. Okay, so if you have a positive A value, then the vertex is going to be 0, and then whatever this C value is, not going to be 0, 0 anymore. The axis of symmetry, so it's still symmetrical. I think we highlighted it yesterday. It's still symmetrical around the x-axis, or y-axis, sorry. So x equals 0. If the A value is positive, it opens up. And the step pattern can be changed if there's an A value. Then if you have a negative, then the parabola opens down, and the step pattern is now moving down instead of up. If you want to add in like another one where if it helps you do this, so then the reason we math teachers think if we just write plus C, then you'll know that negative C is the same thing. That's fine, but maybe not, right? So the vertex moves down. If it's positive, it moves up. Or is shifted. Okay, so now again, we're going to do the same thing. We're going to graph using the vertex and step pattern, but we are not going to make a table of values. So how does it open? It opens up because it's positive here. The step pattern we've already done is 1A, 3A, 5A. 1 times 0.5, 3 times 0.5, and 5 times 0.5. But the vertex has been shifted down. So it is going to be 0 and -7. So that's where we need to start, 0 and -7. And we're going to go over 1 up a half, over 1 up 1.5, over 1 up 2.5, over 1 up a half, because we want symmetry, over 1 up 1.5, over 1 up 2.5. Okay, so again, label that A. So again, you can see the vertical compression, it sort of looks fat, okay, because that was a fraction out front. Now for B, it opens down because of the negative. The step pattern is 1 times -3, 5 times -3, and, oops. Sorry, that is really messy. Let me just fix that. 1 times -3. 3 times -3, and 5 times -3. Squishing. So -3, -9, and -15. And then the vertex is 0 And because that's positive and 10. To be honest, usually if we give you a grid, then your graph should fit nicely on the grid. So let's say I forgot and I did negative 10 and the parabola opens down. That means I would start here and then I would go this way. It doesn't fit on the grid. So then that's kind of your clue. Whoops, that doesn't seem right. So here, when we do 0, 10, positive 10, because it's a positive, then we go up. Now we can go down, right? So just be wary of that, okay? So over 1, down 1, 2, 3. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, let me do that again. Over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know. I don't think I'll get 15. Yeah. Over 1, down 3, 1, 2, 3. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the homework to practice this, and I really recommend that you try, I'm going to put a blank piece of graph paper on inside the module if you want it. This is actually from section 6.1, which is weird, but it doesn't matter. So try these questions, and when it says to graph, do the graph and try to do it using the opening, the step pattern, and the vertex. Okay? If you have any questions, please email me. Thank you.